welcome to Engineer's Workshop. By the time you're watching this video, day 100 in Putin's war on Ukraine. So finally got some machining content for you today. What I've got to do is I've got to flatten another differential cover for my son's Spitfire project. He remade his fabricated differential cover. The original one fit, size was right and everything, but once we milled off the back side of this weldment, which got distorted, he lost just enough clearance where the ring gear was grazing the inside of the cover. He didn't want to put a 1/8" gasket spacer or anything on that, so he remade the part with a thicker base plate. He went up from 1/4 to 3/8, and these parts he made from the Send Cut Send service, where he just sent DXF files in for all the little pieces, and back come all the pieces in steel, shrink wrapped on a piece of cardboard. So let's show you the setup, and we'll get working on this. Had to remove the big rotary table off the mill and swap it out for the big vise. So let's go over and check out the new part. So here's the new differential cover, and this, like I said, was all the parts were cut from Send Cut Send. That is the same outfit that there we go. Same outfit that did my hook wrench for the K&T, and he welded this up, and he got, despite the fact that he had a thicker base plate, he got the same warpage. So we've got rock in this direction and rock in this direction. I'm going to use a slightly different approach. I'm going to put this on the 3 standoffs once again and clamping on the sides, but since the low points are at the corners, and I've established that from the previous cover that I milled, I'm going to offset I'm going to center up the K&T spindle on the center, offset the head, and then just start using the rotary axis until I get basically a full cleanup at the corners, or at least, inside the bolt circle. And then as it goes around, I will just bring the head in, and the depth of cut will increase as it comes toward the center. It's still only going to be 40 to 60 thousandths deep at the center versus at the corners, but I think it'll be the most efficient way of doing it, going for the low spots first and then just coming into the center, and when I'm at the center, I'm done. So let's go do the setup for this operation. Yesterday I unloaded the Troike 18-inch rotary table with the aid of the overhead hoist and trolley. I had to bring it over top of my son's Spitfire, chewing my nails a little bit, but I haven't dropped anything yet. So let's raise the hut on the K&T, and I've got to borrow this rigging to put the large vise, which I can't lift by hand, in place on the table of the K&T. Note to self, this vise is trammed, this vise is not trammed. My son got his frame back from the sandblaster. This is for the Spitfire. He has new outboard body supports. He has modifications to clear the T5 transmission. And at the rear, a trailer hitch. That entire rear frame section has been added. So this is ready for paint. The cable guides for the parking brakes were brazed on. That's from the factory. Quick update on the Miltronics. I've not had an opportunity or the means to be able to move it off of its rigging point here near the back entrance of the barn. So what I wouldn't do for a 5,000 pound capacity pallet jack, something to get it over this rough floor, I've got to move it about probably 30 feet to a better resting place. I also need to move the Cincinnati tool and cutter grinder from underneath the overhead hoist. Then I'll actually have some room to unload something else. I got a little bit of a surprise when I opened up the controller. So inside the controller, I have two ISA boards which are just laying in here loose. These require the full, I guess you call it the double slot, both the long and the short. Now there's some additional card slots here that don't have that second set of terminals. So I don't know if I have enough of these or what. The other issue is some of these ports are labeled, you know, F5, F6, COM3, XP3, etc. And the cabling that I have, this is COM2, is not long enough to reach some of its intended sockets. So I don't know what to do about that. I might have to look and see if these boards are in the correct place. Hopefully there's a diagram, or somebody might know what this controller is supposed to look like. But until I've got everything plugged in and you know, at least seated and all the cables connected, I don't know how much progress we're going to be able to make on getting this thing up and running. Okay, I've got the second differential cover with the thicker 3/8 thick base plate fixtured up in the vise on two spacers. Yes, they are wood, but I cut these and planed them and then cut off the two pieces adjacent to one another. And I indicated at the four corners just by sweeping the head, I'm within 5 thousandths TIR at those points. So don't let it be said you can't do accurate work with wood. I've got a piece of brass in here along the back edge so that this will equalize any differences in the edges of this casting. And I've got my scale, my head offset the maximum 4 inches. You can see how much the dovetail slide is protruding there. So this will swing a radius, and that radius with a 3/4 inch cutter just makes it and encompasses the entire perimeter of that piece. So I'm going to slow the head down a little bit, and then we're going to bring the quill down until I just make contact and clean up that circular path, and then we'll just bring the head back in towards center, keep making circles until the entire part is cleaned up. Okay, I reduced the head RPM to 1 RPM. I can use my new quill lock to put a little bit of resistance. So we don't wander. Come down until we touch, and then we will creep down on the depth until we do a full cleanup. come down 5 thousandths more. So we have a tiny bit here and a tiny bit here that didn't clean up. That's outside the bolt circle. So I think we're good with that depth. And basically what I'm going to do is I'm just going to bring the cutter in about 5/8 of an inch per rotation and keep on going around. Six hundred thousandths. You can see how the depth of cut is getting deeper as we go in. That took about a quarter of the time of the original. I wish I would have used this technique when I did his first cover, but let's deburr this. There we have the finished product. Kind of a neat pattern on the underside. Circular, almost looks like you did it in a lathe or on a rotary table, but we didn't need the rotary table. So tiny bit, didn't clean up here, here, here. Actually just all four corners, just a touch. But everything that the gasket surface clamps on is going to be basically perfectly flat, and hopefully he's left with enough clearance in here for the ring gear. So putting it up on the auxiliary table, we got no discernible rock, nothing in either direction, so I'm pretty sure that this stayed basically flat within a couple thousandths even after the machining operation. You know, every time you remove metal from a weldment, if the weldment was not stress relieved, you've changed the dynamics of the part, and this thing will, you know, continue to move as you remove metal, but in this case not enough to make a difference. So we'll call this a success and move on to other projects. I think I've got about 4 or 5 Spitfire parts for the auxiliary drive stacking up behind me. A couple of those are lathe parts, so we should have some pretty good variety of machining projects coming up for you in the near future. Well, I hope you enjoyed that little machining operation on the K&T rotary head mill. Perfect operation to, you know, use that head axis to mill the rectangle flat. If I had a big lathe with a 4-jaw chuck, well, I do, I have the Monarch, but that thing's a long way from being able to hold a part like that in the 4-jaw chuck and just face it off. The Acroturn 1340 is not big enough to hold that part without, you know, a faceplate and a lot of fixturing. So got to use my hook wrench for the adjustment of the quill. I'm going to have to put roundovers on these edges, which is going to make this a little bit more friendly on the hands to handle. But did a good job. Put the big vise on here. Big vise is not trammed. Little vise is trammed. I'm going to have to remember that. And we'll leave this set up for now until the next project. I know what's coming next. Spitfire parts. Keep pecking away at the Miltronics. There's a lot of troubleshooting to do on that controller before I try to power it up again. I don't know if I'm missing parts, if I'm missing cables. We'll just have to see. Have to tap into the power of the internet and the people that have equipment like that and see what I can find out. One gentleman did chime in on Practical Machinist, said that the program, in other words, the CNC program that runs it is burned into an EEPROM, so that should not be lost. So I don't know exactly what loses, you know, what parameters get lost when you have a long power off state like this thing had. But I can't even get the screen to come up to know, you know, what to troubleshoot next. But I'm really anxious to get that thing running, be able to do some, you know, 5 horsepower milling cuts with that. 32 inches of X travel, yeah, just tremendous compared to, you know, this is 18, 12, and I believe 18 on the knee. That's 32, 16, 5 on the quill, and a 12-inch adjustable knee for positioning the work. So broadening our capabilities as we go here. Until next time, everybody stay safe, and as always, pray for our brothers and sisters in Ukraine as the war enters its 100th day.